Hello children, welcome to aimstoday's online classes. In today's video from mathematics subject, progressions topic we are going to discuss. Let's start with the concept of sequence, children. Here, sequence means an arrangement of numbers. An arrangement of numbers. One number is designated as the first. The another one is designated as second. Next one as third, and so on, is known as a sequence. So like 2, 4, 6, 8, and so on. So this group of numbers is called as a sequence. Group of numbers is called as a sequence, but this group of numbers or this arrangement of numbers, it should be in some definite order. It should be in some definite order according to some rules. If you take this example, here 2, 4, 6, 8. All the numbers in the group or in this arrangement, they are in which order? The first number is 2. We are getting the second number by adding plus 2 to the first number. 2 plus 2 equals to 4. 4 plus 2 equals to 6. 6 plus 2 equals to 8. So this group of numbers or this arrangement of numbers is in definite order. So it is known as a sequence. It is known as a sequence. And the various numbers present in the group are called terms. They are denoted by term 1, T1, term 2, T2, term 3, T3, term 4, T4. So the numbers present in the sequence are denoted with the symbols T1, T2, T3, etc. or sometimes A1, A2, A3 and so on. And so on. So sequence means arrangement of numbers, they are which are following a definite order. That arrangement of numbers or group of numbers is called as a sequence. So all the numbers present in the sequence are considered as terms and they are denoted by the symbols T1, T2, T3, T4 or A1, A2, A3, A4. Next. So here in T1, here 1 is considered as subscript. The subscript in T1, T2, T3, T4, in all the terms we are having subscripts. In the place of subscripts we are having 1, 2, 3, 4 some numbers. So the subscript of the term, the subscript of the present in the symbol of the term, it denotes the position of the term. If there is T1, we have to assume that it is first term. If there is T2, it will be second term. If there is T3, it is third term. So these are the this will denote the position of the terms in the sequence. So the number occurring at the nth place of the sequence, suppose 2, 4, 6, 8 and so on. We are having terms. We are having terms like this up to n, which is a variable. It may be 10th term, it may be 20th term, but it is a nth term. So the subscript in the place of nth term will be, or nth term can be written as Tn, where n will be in the place of subscript. Or this Tn is called general term of the sequence. General term of the sequence. Based on that, we can find any term. We can find any term. So let's see how we can find any term. Let's take this example once. So let us consider a sequence of squares of natural numbers. So we are going to take a sequence which is consisting of squares of all natural numbers. Means we have natural numbers 1, 2, 3, 4, 5 and so on. So natural number squares means we can write 1 square, 2 square, 3 square, 4 square, 5 square. 1 square value is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. So T1, T2, T3, T4, T5 are the terms which are the squares of natural numbers. Which are the squares of natural numbers. So based on this, we can write the sequence as 1, 4, 9, 6, 15. For first term, we are writing n1 square, second term value 2 square, third term 3 square, fourth term 4 square, like that. If we have nth term in this particular sequence, that nth term will be n square. That nth term will be n square. So the general term of the sequence Tn is defined such that Tn equal to n square. Based on this definition, we can find any term. If you want to find 11th term, T11 equal to, we can write it as 11 square, which is equal to 121. So first, based on the relation given in the terms, we have to frame a formula for general term, and based on the general term, we can find any other term in that sequence. Suppose, let's see this example. Write the first three terms in each of the sequence defined by Tn equal to 3n plus 2. So in the question, they have given the definition of general term. They have given the formula for general term. Based on that, we have to find the first three terms of the series. So we have the formula Tn equal to 3n plus 2. If you want to find first three terms, so we have to put n equal to 1 and n equal to 2 and n equal to 3. If we keep n values, so we will get first three terms of the sequence. So suppose if you put 1 in the place of n, then Tn will be, if you keep 1 in the place of n, subscript will change to 1 in the left hand side. It will be the first term, and in the right hand side, 3 into 1 plus 2. 3 plus 2, which is equal to 5. So we got first term. If you keep n equal to 2, then the left hand side term will become T2. Second term, right hand side term will become 3 into 2 plus 2. 6 plus 2, that is equal to 8. We have got the second term. If you keep n equal to 3, left hand side we will get T3. Right hand side 3 into 3 plus 2, 9 plus 2 equal to 11. So as per the definition of general term, so for the given sequence, first three terms will be 5, 8 and 11. 5, 8 and 11. Like this. If you know the general term, we can find the we can find whatever term we want, that we can find. Next we have progressions. So if the terms of sequence follow a certain pattern, then the sequence is called a progression. If the terms of sequence can be described by an explicit formula, by a definite formula, then that sequence is called as a progression. If there is one particular formula between the terms, so then that sequence will be considered as a progression. So here, these all sequences are considered as progressions. First one, if you take the first one, 3, 5, 7, 9, and so on up to 21. In this, what formula is involved in this sequence means, so each term except the first is formed by adding 2 to the preceding term. So each term except the first, whatever terms are there, they are formed by adding 2 to the preceding term. 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, and so on, up to 21. So they are having this sequence is having a definite formula. So it will be a progression. So it is considered as a progression. So the second one, if you observe the second one, 8, 5, 2, minus 1, minus 3. Here, 8, 5, difference is 3. 5, 2, difference is 3. 2 minus 1, difference is 3. Minus 1 minus 4, difference is 3. Means each element except the first term, each element is obtained by subtracting 3 from its previous number. That is the relation existing in this sequence. So, as there is one particular relation, this sequence will be considered as a progression. So here, in second question, each term is formed by subtracting 3 from the preceding term. Or third one, 2, 6, 18, 54, and so on, 14, 58. 2 3 times 6, 6 3 times 18, 18 3 times 54 means each term except the first term is obtained by multiplying 3 with its preceding term. So each term is formed by multiplying the preceding term by 3. So that is the relation in third one. So fourth one, 1, 1 by 2, 1 by 4, 1 by 8. 1 will become 1 when divided by 2, it will become 1 by 2. 1 by 2 when again divided by 2, it will become 1 by 4. When divided by 2, it will become 1 by 8. So here, each term except the first term are obtained by dividing its preceding term with 2. By dividing its preceding term with 2. So this is also having one definite formula. This is also will be an example of progression. So in fourth case, each term is formed by dividing the preceding term by 2. So from 1 to 4, whatever cases, whatever examples are given, all are progressions. All are progressions. So whereas in these progressions, as there is ending element, last element, this is finite progression. Here also ending element is there. Number of elements are limited. So these two are considered as finite. Means number of terms are limited. Finite progressions. Whereas these two, as we have dots at the end, there is no end element. Means it will go on like this forever. These two progressions will never end. These kind of progressions, we call them as infinite progressions. Number of terms we cannot count, they are infinite. So in progressions we have two types of finite progressions and infinite progressions, or finite sequences, infinite sequences. Okay, next year we have series. We have a series. So a series is obtained by adding or subtracting the terms of a sequence. Now, in these examples, whatever terms are given, if we add all of them, then their sum or difference will be considered as a series. So here 3 plus 5 plus 7 plus 9 up to 21. If we add all of them, it will become a series. It will become a series. So series, series. So this series can be finite or infinite according to the number of terms in the corresponding sequence. If the sequence is having finite number of terms, then the series will be finite. If the sequence has infinite number of terms, then the series will be infinite. So a series can be finite or infinite depending on the number of terms in sequence. So these are all. The sum of all, sum of all, sum of all, sum of all, sum of all. These are all considered as series to their corresponding sequences. So let's see the example. So find the next term of the following sequence. So 2, 1, 1 by 2, 1 by 4. So here, if we observe, so there is some pattern visible here. So how we have got this sequence means, so each term is obtained by multiplying the previous term by 1 by 2. So suppose here first term 2 is there. If you multiply with 2 by 2, we got 1. We are getting this element. So previous term is multiplied by 1 by 2. Or next 1 is there. If you multiply with 1 by 2, we will get 1 by 2. Or 1 by 2 is there. If you multiply with 1 by 2, we will get 1 by 4. Means each term is multiplied with 1 by 2 for getting its next term. For getting its next term. So 1 by 4 after next term will be 1 by 4 also to be multiplied by 1 by 2, which is equal to 1 by 8. 1 by 8 is the answer. So if you see this example, minus 1, minus 3, minus 5, minus 7. So here, second term, how it has been obtained? By subtracting 2 from the previous one. So minus 3. From minus 3, again if we subtract 2, it will become minus 5. From minus 5, we subtract 2, it will become minus 7. So each term is obtained by subtracting minus 2 from the previous one. So minus 7 after, next term also minus 7 minus 2, which is equal to minus 9. So the next term is minus 9. So like this we can find next terms in the sequences. Next example, find the 18th term, 25th term terms of the sequence defined by Tn, n into n plus 2 if n is even, 4n by n square plus 1 if n is odd. So what is Tn here? Tn is the general term. Tn is the general term of the sequence. General term of the sequence used to find various terms in the sequence. But here Tn is defined in two ways. If n is positive, n is even, then this definition we have to consider. If n is odd, this definition we have to consider. So now we have to find 18th term. So n value will be 18. So n is even, first definition we have to take. If n equal to 18, which is even, then T18 will be n into n plus 2, where n value is 18. So 18 into 18 plus 2. 18 into 18 plus 2. 18 plus 2. So 18 plus 1, I think children, it's not 2, it is 1. 18 plus 1. 18 into 18 plus 1. 18 into 18 plus 1 equals to 19. 9, 8 times 72. 7 remaining. 9, 1 is 9 plus 7, 16. 1, 8 is 1, 8, 1, 1 is 1. So 2, 14, 342. So answer will be 342. Please note down, change it as 1 children. So next, 4n by n square plus 1. Here, next term is 25th term, n equal to 25, which is odd. Then T25, 25th term value will be, so in the subscript we have to place 25, it will be 25 to 25. And 25 is odd, this definition we have to consider. So 4n by n square plus 1, 4 into n value 25, 25 square plus 1, 4 into 25, 100, 25 square 625 plus 1, 626. If you cancel with 2, 250z, 2 313z, no other cancellation. So answer is 50 by 330. 50 by 330. Okay, children. This is about sequence and progression. So what we have learned today about sequence we have learned today, and about general term we have discussed, and about progression we have discussed, and about series we have discussed, and there may be a finite series and infinite series based upon finite sequence, infinite sequence. So remaining topics we can learn in our next video, children. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.